Hello everyone and welcome to a new problem of the strings chapter. This problem is a classic one, it is not very hard, but it's just perfect to make sure that we have understood strings and to really get used to them. So, the statement is simple, we are given a string and we have to check if that string is a palindrome. So first of all, let us remember what is the definition of a palindrome string. A string is a palindrome if it reads the same backward as forward. Let's take a look at these two examples. First example, we have the string A, B, C, B, C, B, A. So what I have to do is see how this string reads backwards and check if they are the same. So how does it read backwards? A, B, C, A, B, C, B, C, B, A, B, C, B, A. And let's check them. A, B, C, B, C, B, A, A, B, C, B, C, B, A. They are equal. Awesome. So this is why we output true. This string is indeed a palindrome. Let's take a look at the second example. I have A, B, B, X, B, A. Let's see how it reads backward. And it will be A, B, X, A, B, X, A, B, X, B, B, A, B, B, A. Now let's compare these two. A, B, B, X, B, A, A, B, X, B, B, A. So the first two characters are indeed equal, but the third one are different. So these are not equal, which means that our string is not a palindrome, and indeed we will return false. Alright, what I love about this problem is that the first solution and the simplest one lies in the definition of the palindrome. What did we do here? We have reversed this string in another one and then compare if these two are equal. So obviously this is a way of solving this problem. We'll first have to reverse this string into a new one. So first of all, let's say S prime is going to be equal to reverse string of S. And how should we do that? Well, first of all, this could be a built-in function, right? You can use a function like reverse, or you can use some syntactic sugar in Python, for example. There are multiple ways of doing this in one line of code. And what you should do in a coding interview is actually ask the interviewer if he is okay with just using a built-in function or the syntactic sugar. Most probably the answer is going to be no. And what you should do in this case is, of course, remember that we have just solved this problem in the reverse string lesson. So what was the solution there? We had the string, and what we did is that we have swapped each of the correspondent letters that needed to be swapped, right? The first with the last, the second with this one with this one, right? We have swapped all of this and we ended up with the reverse string. You need to be careful about one thing though. This solution reversed our string in place. So at the end of the algorithm, in the variable s, we will have the reversed string, and yes, we are going to lose its original value. So if you really want to go with this solution, that's completely fine, but make sure that you make a copy of the original value of s first, you reverse that copy, and then you compare the original s with the reversed copy. And the easiest way to do this is to write the code from reverse string inside a function, just like we did here. And why is that? Because when we have a function, reverse string, and our argument is a string, let's call it s, right? And this function is going to change our string and let's say return it in the end, right? What's going to happen is that our original s in the main algorithm, this one, is not going to be the same object as the s here, right? Remember, when we call a function and the arguments are not stored by reference or by pointers or something that has direct access to that zone of memory, what happens is that the original object is being copied in another object. So, inside the function, we are going to modify the copy, we are going to return it in the end, and the value of s prime is going to be the reversed s, and the s will stay the same, will indeed be the original one. And here we can do the second step, which is of course check if s is the same string as s prime. And I'm pretty sure that in every language you can check this either with syntactic sugar or with a built-in function, so it's very simple. Again, Ask the interviewer if he is okay about this. If he is, awesome. If not, guess what? You can make a for loop and literally check each two corresponding characters. S0 with S prime of 0, S of 1 with S prime of 1, and so on and so forth, right? Cool. So the code is very simple. There's no need to write it here. Basically, I have only this line, and you will make sure that you are going to implement this function, right? And the argument is not stored by reference or a pointer, and the code inside the function, you have it in the reverse string lesson. And then basically I have this line in which I check these two, and this is your homework to see how you can check this with a built-in function or syntactic sugar. And if you don't find any, that's completely cool. You can write a for loop and yeah, practice on for loops. Awesome. Now let's analyze the time and memory complexity of this approach. Remember that reversing a string with this approach was big O of n time complexity and constant memory. Very good. Now, what happens is that we call the function and we store the result in another string S prime. So this one is going to be, of course, big O of n time complexity, and the memory complexity will also be big O of n. And why is that? Because first of all, we make a copy here. S prime is another string of length n, and even if we didn't do that, we also make a copy in this argument, right? Like I've explained you. So this is big O of n with also big O of n memory. And what's this? Big O of n time complexity. And of course, we don't have any extra memory for this one. It's just a for loop or a function call. So the final time and memory complexities of this approach are big O of n and big O of n. Let me write it here. Big O of n and big O of n. And my question is, can you find a solution which still runs in big O of n time complexity, but uses only constant extra memory? And the answer is not only that it's possible, but it's actually way easier than the previous solution. Let me show you why. I've taken here a string S consisting of 6 characters. I don't care about the values of the characters, I just denoted them by S0, S1, S2, S3, S4, and S5. Now, when I'm gonna reverse this string and build my S prime string, it is going to look like this: S5, S4, S3, S2, S1, S0. So the indices in reverse order. Then, in order to check if those strings are equal, what we basically do is check if S0 equals S5, S1 equals S4, S2 equals S3, S3, S2, S4, S1, and check if S5 equals S0. And all of these have to be satisfied in order for our string to be a palindrome. Okay, do you notice something here? We check S0 with S5. So we check if the first character is equal to the last one. Then we check S1 with S4. So the second one with, of course, the fifth one. Then S2 with S3, right? S2, S3. Then S3 with S2, we already did that. S4 with S1, we already did that here. S5 with S0, we already did that here. So all that we do here is start with the pair consisting of the first and the last characters, check if they are equal, and if so, continue. From the first one, move one step to the right to the second one, and from the last one, move one step to the left to the second last one. Check if those two are equal, and if so, continue. One step to the right, one step to the left. Check if those two are equal, and here we stop. So basically what we do is follow the exact algorithm that we used for the reverse string problem. But this time, instead of swapping the characters, we just check if they are equal. If so, we continue and check the next pair. If not, we can return false and terminate the algorithm. And in order to do this, if you remember that approach, I'm just going to write the pointers here. I'm not going to write the code because it is 99% the same. All we did was have 2 pointers, the left and the right, check for equality, increment left, decrement right, check for equality, and so on and so forth, until we either finish, for example here, left, right, we finish. This means that left is here, right is here, so left became greater than right, or we find a pair of characters which are not equal and we return false. And that's it, guys. The time complexity of this algorithm is the exact same one as the algorithm that we have used to solve the reverse string problem, which was big O of n, because obviously each character from this string is visited at most once, and the extra memory used is also constant. So we have a solution with big O of n, time, and constant extra memory. Alright guys, again, this was simple. It's just a warm-up to get used to strings. I hope you really enjoyed it and have fun coding. I'll see you on the next one.